In this video, I'm going to do an end-to-end walkthrough of building out a grid-style inventory using Nova. The inventory will consist of two grids, both of which are dynamically populated using Nova's data binding APIs. The character grid on the left will be a fixed size grid, while the Armory grid on the right will be much larger and scrollable both with the mouse wheel as well as a draggable scroll bar. We'll also use Nova's gesture API to add a variety of interactions such as animations, clicking on an item to pick it up and move it around, and right-click and drag to split an item into two different groups, and then recombining items of the same type. So let's go ahead and jump into Unity and get started. This is a new Unity project that I just created. All I've done is I've gone ahead and imported some of the things that we'll be using. This, of course, includes Nova and TextMesh Pro, as well as some textures, meshes, and a font. There will be links in the description to all the assets that we use, as well as a repository with the final sample code. Let's go ahead and create a new scene, which I'll call Inventory. I'll switch to that, and I'm just going to do a little bit of setup here. I'm going to add this inventory background prefab, which you can find in the repository linked below. And I'm just going to set the lighting intensity down to 0, just to give us some background in which to build our inventory. Now let's add the root of our inventory, which we'll call inventory panel. This is a UI block 2D. The way I'm going to set this up is I'm actually going to give this a size of 1920 by 1080. And these are world space units. And since I don't want the panel to actually be 1900 meters wide, I'm going to set a scale of 0.001. And the reason I do this, work in these larger units here, it's totally user preference. You don't have to build things this way, but it just makes building out our content later on a little nicer because we can use larger numbers. So for example, if I add another UI block, which I set the size to be 1.92 by 1.08. So it's the exact same world space size as the inventory panel. If I want to add a small border here, I have to use a value of, say, 0.01, whereas with the inventory panel, we can use a value of 10 to get the same border. So it just lets us use larger units as we go and build out our content. Again, totally user preference. You don't have to do it, but this is how I'm going to build out this sample. So let's go ahead and get rid of this border and set the color of the backing panel. I'm going to pick some dark color or something like that. I'll add it to the swatches so we can reuse it later. And let's go ahead and add another UI block 2D for the header. I will top align it and fill the width. Now I don't actually want the content of the inventory panel to come all the way out to the edges. So what I'm going to do is I'm going to add some padding to the inventory panel. And if we switch to scene view and switch to the padding and margin tool, you can actually see the padding that we've added and even adjust it here, but we'll leave it at 32. Now let's go ahead and size up the header to be somewhere around there. And let's go ahead and add a label here. The label will say inventory. We'll use the bold font, and let's go ahead and shrink the on the auto size here. And the reason I do that is because otherwise the text would wrap to maintain within the size of the block, but since I set it to shrink, it'll actually expand so that it hugs the size of the text. So now let's go ahead and left align it and bump it out from the right a little bit, something like this. And the last thing I'll do is I'll change the color. I'll start with the panel color, but then bump up the brightness a little bit just to give us kind of two dark tones that we can use. Now for the actual color of the header, what I'm going to do is I'm going to use the backing panel color because then I'll add a white gradient. So let's pick a white, just tone it down a little bit. And the way I want a horizontal gradient. So the way you can accomplish this is by setting the radius on one of the axes to 0. And I'll set the radius on the x-axis to 150% and then the x position to -100. So it kind of fades across the entire header. I'll also add an accent to the left side of the header, which I'll fill the height, and I'll use that same white color as we used for the gradient. There we go. So now let's add a root for our close button, which I will right align, and now I'll add an actual button. So this is UI block 2D. And I want this to be circular, so I'll lock the aspect ratio, I'll bump up the size. Let's go ahead and zoom in. I'll round the corners. Let's set the size to be that lighter dark tone, and let's go ahead and add a border. And now we can pick our accent color. I'm thinking a gold, something like this. And then let's bump down the brightness a little bit. That looks pretty good, so we'll add that to our swatches. And let's increase the size of the border a little bit. There we go. So now let's add the X. So this is X1. We'll set the size to be about 50% on X and 2 on Y, and then we can round the corners. And let's rotate by 45 degrees and also use white here. So now I'll duplicate that and rotate it by negative 45 degrees. So then we have our kind of X. Perfect. So now let's also go ahead and add a label, which will say close. And for this, we're going to use the medium font. Let's use a font size of 320, and we'll shrink again so that the block resizes to fill the text. And we're going to use that same white color, and let's actually left align the text and right align the button. And that way we can reposition these by just resizing the parent. So something like that. Perfect. Now let's go ahead and move it up. And so you'll notice we're getting edge snapping here. It's snapping to the bounds of the header, but I don't actually want it quite on the edge, so I'll bump it over a little bit. Now if we zoom back out, that looks pretty good. So now let's go ahead and add a body, which I will bottom align, fill the width, and then let's size it up. Something like that looks pretty good. Now let's add a divider, which will come between the header and the body. So I will fill the width, we'll set the height to about 2, we'll use our lighter dark tone, and let's go ahead and move it up so that it comes roughly between the header and the body. I'm not being exact here, so we'll adjust the body and make it a little bit bigger. Perfect. So now let's add a root for our character grid, which I will left align, fill the height. I'll set the size to be 49%. So that way, when we add our other one, there's a little bit of space between them. And we'll add a header to this as well. This will be similarly styled to the primary header. So we'll expand the width. We'll set the size to be not quite as big as the primary header. We're going to color this in a very similar way. So we're going to use the primary panel color. We'll use the white as the gradient, totally horizontal, 150% size. But we're actually going to make the gradient go the opposite direction, just to kind of change things up. And we'll add a label here as well. This one will say character, and we'll use the semi-bold font. Let's size it to 480. And then we'll shrink here as well. We will use the white color for the font. Let's go ahead and left align it, and then we'll bump this out a little bit as well. Something like that. Let's go ahead and add an accent like the primary header. So we'll use that same white color. We'll fill the height and left align. There we go. So now let's go ahead and add an icon. And so what we're going to do for the icon is we're going to have 3 swords side by side. So we'll lock the aspect ratio here and we'll set the size to something like 70. Now let's go ahead and add the swords. So we can set the texture here to be the sword. Let's go ahead and actually lock the aspect ratio and then fill to the parent. We'll bump up the brightness a little bit, and let's rotate by 45 so that it's vertical. So now if we could duplicate this 3 times, and we can actually use auto layout to align this nicely for us. So let's go ahead and bring these in, and then we can bump out to the left a little bit. There we go. So now we have our header. Let's go ahead and add the body. So this will be the parent of the grid. And we will expand to fill the width. We'll bottom align it, and then let's go ahead and size it up to about there. And now we'll add the actual UI block, which will contain the grid. So we'll fill and fill. We won't render the body, but we will add a border here. We'll use that dark tone, and it's something like that. Perfect. So now that we have this, we can just duplicate this for the Armory. We can right align it, and then now we can just tweak some of the colors to style it a little bit. So for the gradient color, we'll use this gold accent color. The label will say Armory. The accent we also want to be gold. And for the icon here, I actually want the swords crossing. So I'll disable auto layout here. I'll get rid of one of the swords. I'll center these, undo the rotation, and then I'll rotate this by 180 on Y. And now let's go ahead and give these a gold tint as well. So that looks pretty good. So now that we have our inventory panel built out, we want to start populating it, but before we do that, we actually need a data source. Now, if this was a game or an app, you would hook it up to your actual data source, but since this is just an example, I'm going to create a dummy data source. So let's go ahead and add a scripts folder and a item database. So the first thing we need to do is create the type of our data, which we'll call item description. This will be pretty simple. We'll just have it have a name and a texture for the icon. And then since we're going to populate this in the editor, we'll go ahead and mark it as serializable. We'll make our database a scriptable object, and then we'll add a serializable list of item descriptions. There we go. And the last thing we need to do is we need to add this create menu, asset menu attribute so that we can actually create an instance of this. So now if we switch back to Unity, we can create an instance of our inventory items and populate it with some values. I'm going to fast forward through me filling it out, but once we have it populated with some dummy items, we can switch back to Visual Studio, and let's create a method that the rest of our code can call to get a list of random items. So first, we'll create one more type, which we'll call inventory item, and this will just contain an item description, as well as a count for how many items are stored. And let's also go ahead and create a representation for an empty item. Now, there's many ways you can do this. You can use null if you wanted to, but I'm just going to use a static instance. And we'll also add an isEmpty check, as well as let's add a max count, and let's say 50. So now let's go ahead and add the method, which will return some random items. It's going to take an account, and this will be the list that we want to return. And let's make about half of the items that we return be empty. So we'll add a random check if it's greater than 0.5. We'll just add the empty item. Otherwise, we'll pick a random item from the list of items. And this is items.count. And then we'll also set the count to be a random value between actually 1 and the max count. So now let's go ahead and we need to actually return that. And now let's go ahead and switch back to Unity. Now that we have our database populated and ready to provide us with some data, let's go ahead and create the visual representation for an inventory item. So I want this to be square, so I'll lock the aspect ratio. I'll set the size to be 100. Let's go ahead and make the background color that lighter dark tone, and we'll add a black gradient here, with the gradient to be horizontal, and then I'll just kind of fade it across the body, something like that. And we'll also add an inner shadow, which will make that white color. We'll zero out the offset, and we'll bump up the blur a little bit. Perfect. And now I'm going to add a content root, and the reason I do this is just so that way I can use the same prefab both for empty and filled slots. So if the grid is empty, I can just disable the content root. Otherwise, it'll be enabled and show the rest of the visuals. You can have multiple prefabs if you want. It's up to you. So let's go ahead and expand the image. Let's throw a dummy texture in there. We'll set the color to white so it's full brightness. And I actually don't want it to come all the way out to the edges, so I'll add some margin. Now let's go ahead and add a count bar, which will bottom align, we'll expand on X, we'll have it be that lighter dark tone as well. And now let's go ahead and add the fill, which we will left align, we'll expand on Y, we'll have it be that gold accent color. And the size here doesn't matter, we'll change it in code later, but it'll just slide as the count changes relative to the max size. And now we'll go ahead and add a count badge. So this will display the number of items in the grid slot. So let's go ahead and add the label here for that. We'll have it be, say, 20 for now. We'll shrink this. We'll have it be a font size of 200, and let's use the bold font. And we'll also have it be that lighter dark tone, so that way we can have the count badge use this white color. We'll shrink the count badge so that it also hugs the text, and let's go ahead and add some padding on the left and right side to give it some breathing room. We'll also round the corners here. And I want it to be circular in this situation, so let's go ahead and add a min X and Y size. And now we can add a border, which will also make that gold accent color. Let's bump it up a little bit. And let's go ahead and add a black inner shadow as well. We'll bump up the alpha so that it really pops. And something that like that looks pretty good. Let's go ahead and reposition it a little bit just so that it's in the bottom right corner. And since this is kind of an overlay, in case it overlaps with any other inventory items, I actually want this to render on top. So I'm going to bump the Z index of the count badge and the label up to 1. And then the other thing is, since this overlaps with the count bar, I don't actually want this fill bar to come all the way to the edge. So let's go ahead and adjust the padding here. Something like that. And so now if the fill is 100%, it will only come out to here. And also I want to explain the reason that I am shrinking the count badge to the text is that way if we decide later to add extra characters, the count badge will resize, to properly handle that. So that looks pretty good. So now let's go ahead and turn this into a prefab. We'll delete it for now, and let's go ahead and stub out some rows. So this is just for styling purposes. We're actually going to delete these later before we actually do the real data binding, but just to get an idea of what this will look like. So I expanded the row and I have it shrinking so that it hugs the height of the inventory items. Let's go ahead and duplicate this a few times. We will auto lay out the row on X, and we'll have it auto space so that it kind of evenly distributes things. And let's go ahead and add one more. And I'll also add some padding just to kind of space things out nicely. So that looks good. Let's go ahead and change up the color. So I want a white gradient, kind of an arc along the bottom. So let's go ahead and we'll set the Y position to negative 100%, and we'll set the radii to 80%. And I don't remember if we made it use that white color. Let's go ahead and also have the body be that same white color, but we'll drop down the alpha, and that way we get this nice arc that fades into totally transparent. And let's go ahead and also auto layout the grid itself, which will auto layout on Y, and we'll duplicate the rows a few times. This looks good. So this character grid is actually going to be statically sized, or the number of items won't change. So I actually want this to fill the entirety of the grid. So let's go ahead and bump up the spacing to get it to come down to the bottom. That looks good. And actually the other thing is I don't want these gradients for the rows to come all the way out to the edges. So the way I'm going to handle that is I'm going to create an inner shadow on the grid, which I'll have be the same color as the backing panel. I'll bump up the width and blur. And since the grid comes earlier in the hierarchy than the rows and the items, I actually need to bump the Z index up by 1 as well. And now we have the gradients kind of fade out before they get to the edges of the grid. That looks good. And let's go ahead. I'm going to make sure to apply that same inner shadow here to the Armory grid. So it was the backing panel color. We'll have it be a width and blur of 8 with 0 offset. And let's also make sure to adjust the Z index. Perfect. Now that we have our inventory item prefab built out, and we also have an idea of what the rows will look like, if we take a look at the list view article, this is under the data mining section on the Nova website, and even though it's list view, this applies both to the list view and the grid view. We need 3 things to be able to data bind. First is a data source. This will come from the item database that we set up earlier. We just set up our inventory item prefab, and the last thing we need is an item visuals type, which will actually handle linking an instance of a data type to the prefab that we just created. So let's go ahead and do that. If we switch back to Unity, let's add an inventory item visuals class. So the first thing we'll do is inherit from the item visuals base class, which is in the Nova namespace. And now let's go ahead and add a reference to all of the things that we might want to modify based on the data that we're bound to. So first it'll be the content root, a UI block 2D for the image, as well as the count bar fill, and then a text block for the count itself. And then we'll also go ahead and add a bind method so that we can bind to an inventory item. If the item is empty, then we'll go ahead and disable the content root. Otherwise, we'll make sure to enable it. And then we'll go ahead and update the image based on the item image. We'll go ahead and set the count text to be the item's count. And then we'll set the count bar fill size X% to be, let's clamp it just to be safe. And that'll be the count over the max count. One thing I forgot to do here that I wanted to mention is marking the inventory item visuals as serializable. Under the hood, item visuals use serialized references, which according to the Unity documentation requires the type to be marked as serializable. In the current 2021 version of Unity that I'm using for this sample, it seems to work without it, but it's safer to mark them as serializable. That way, if Unity changes the implementation to match what's documented, things won't break. Let's go ahead and hook this up in Unity. If we open up our inventory item prefab, we can go ahead and add the item view script here, and we should see our inventory item visuals pop up. And now we can serialize those values that we exposed. So the content root, the image, the count bar fill, and the count text block. So now this prefab is ready to be bound to a grid view. So let's go ahead and add a script to actually do the binding. So we'll add a new script here, which we'll call inventory panel. And first, let's just get our character grid working, and we'll come back and do the armory after. So the first thing we'll need to add a reference to a grid view, which will be our character grid. We'll also need a reference to our item database so that we can have it populate some data sources for us. And then we'll also need a list of inventory items, which will be our character items. And if we go ahead and add a start method, we can initialize our character items data source from the item database. And we also need a count, and since the character grid is statically sized in terms of the number of items, we'll just use 24 here since we had 4 rows of 6. So now we'll use that character count here. And now we need to provide the grid view with a data binder. So this is accomplished with the add data binder method, which does 2 things. One, you'll notice it's generic with 2 generic arguments, one for the data type and one for the item visuals type. You can have multiple data binders since you can have multiple data types, whether through inheritance or interfaces, and they can be mapped to different item visuals type. For us, we just have one data type, which is inventory item, and then one item visuals type, which is inventory item visuals. So we'll go ahead and add those. And then the other thing this does is provides the callback, which the grid view will use to bind a data item to an item visuals. Since we implemented a bind method on our inventory item visuals, we'll go ahead and forward this to that. And this user data field on the onBind struct is the actual data item that's being bound. So now we can actually set our data source, which we do with the setDataSource method. And then the last thing we need to do, and this is specific to the grid view, you don't need to do this for the list view, is we're going to add a slice provider, which lets the grid view know how to style the rows or columns of the grid. And this actually has 3 overloads, one with grid slice, one with grid slice 2D, and one with grid slice 3D. These are analogous to UI block 2D, and UI block 3D. So it depends on how you want your rows and or columns to look. So we'll use the grid slice 2D here, and we will style it to be the same as what we had set up in the editor. So let's go ahead and set the layout auto size on Y to be shrink. We will have the auto layout auto space be true. We'll also add some padding, which we had set to 30. And then we also want a gradient on here, so let's go ahead and add a row styling section to our editor, and we'll just serialize a radial gradient here, which will be the row gradient. And then here we can just set the gradient of the row to the row gradient. Perfect. Now let's switch back to Unity and test this out. If we go to our inventory panel, we can add the inventory panel script. Let's add a reference to our item database. We also need to add a grid view to the grid here. So let's go ahead and do that. Cross-axis count, that's the number of items in each row. So we want that to be 6. And we also need to add the prefab, which we want to use our inventory item prefab. We can go ahead and get rid of these dummy rows we added, and then we can serialize that grid view. Now let's go ahead and set up the gradient here. So we use that white color. Let's switch these over to percents. This was -100, and these were 80. Make sure that's enabled, and let's go ahead and see if this works. Look at that. So now we have our character grid dynamically populated from the data source. Let's go ahead and set up the armory to do the same. And for the armory, we essentially want to do the same thing that we're doing for the character grid. So let's go ahead and serialize these same things. We want an armory grid view, an armory count, which we'll use we want this to be much larger, so we'll use something like 200. And we want to do this same initialization here for both. So let's go ahead and add an init grid method, which will take in a grid view, as well as a list of inventory items as the data source. And then we'll move this initialization down here, but we'll use the provided grid with the passed in data source. So now we can call this init grid method with the character grid and the character items, as well as the Armory grid and the Armory items, which we need to create here and initialize as well with the Armory count. So let's go ahead and make sure to use that here. And then the last thing I want to do is I actually want the rows of the character and Armory grid to be styled differently. So I'll add a color for the character row as well as the Armory row. And here in the grid slice provider, we'll set the gradient color based on if the grid view is the character grid, in which case we'll use the character row color. Otherwise, we'll use the Armory row color. Now let's go ahead and hook this up in Unity. First, we'll add a grid view to our Armory grid. And you'll notice that the primary axis here says none, and that's because we haven't actually specified an auto layout for this UI block. So let's go ahead and do that. We'll also use the same spacing as we used for the character grid. So now you'll see that the primary axis says Y. We'll use the same cross-axis item count of 6, and let's go ahead and add in the inventory item prefab. And now we can serialize this grid view with the inventory panel and pick our colors. I'll do white for the character grid and gold for the accent for the Armory grid. Let's play, make sure we hooked everything up correctly. Perfect. So now we have both grids being dynamically populated from the data sources. And you'll notice that the Armory grid only has 24 items, even though we specified a count of 200. And that's because the grid view only pulls in as many items as necessary to fill the bounds of the UI block. So in order to see the rest of these items, we'll need to make this grid scrollable. We can do that using Nova's scroller component. Let's go ahead and add that. And this has a bunch of configuration you can take a look at. For now, we'll just disable this drag scrolling since that's primarily for touch, XR hands, that type of thing, but we just want the scroll wheel for now. In order to use this scroller component, we actually need something to provide input into Nova. So if we take a look at the website, under this input section, this input overview article talks about providing input, and then it has several examples for different input modalities. So let's go ahead and copy this input manager from the mouse article just to get us started. So we'll add a new script here, which we'll call input manager. Let's go ahead and open that up. And here we can paste in that example that we just copied. Let's make sure to rename the class. Now we can switch back to Unity and add the input manager to our scene. So I'll go ahead and create a new game object called input manager. I'll throw the input manager script on there. And now if we play, our Armory grid should scroll. And it does, although a little bit slowly, but that's okay. We can bump up this vector scroll multiplier. So it's scrolling, but you'll notice that the items are rendering outside of the bounds, which is actually kind of nice because we can see the virtualization that the grid view is doing for us. So even though our data source is a size of 200, we never have more than, say, 30 or so items populated at any point in time. But we don't want the items to render outside of the bounds, so we'll go ahead and add a clip mask here. And now they stay within the bounds of the grid view. So let's go ahead and apply those changes. We'll add the clip mask. Another nice thing that the scroller can do for us is it can give us scrollbar functionality. So let's go ahead and add a scrollbar track, which we will right align, we'll expand the height, we'll give the grid some margin, bump it away from the right a little bit, just to give the scrollbar some space. We'll set the track size to 8, and let's go ahead and add a track visual. So this will just be a thin line that the scrollbar travels on. We'll set the width to about 2, and we'll set the color to that lighter dark tone that we have. There we go. And now let's go ahead and add the scroll bar itself. This, we will expand the width, we'll have the height be, well, the height doesn't matter, it'll be changed by the scroller later, but just to make it easier to see, and we'll make it gold. Perfect. So let's go ahead and add the scroll bar to the scroller. And there, you notice there's a checkbox here to make it draggable. So let's go ahead and check that. But when we do that, we get a warning, which is telling us that we don't have an interactable component on the scroll bar. So let's go ahead and add that. This is the component in Nova which listens for input events and fires gestures, and that's what the scroller listens to in order to make the scroll bar draggable. So we'll also make sure to check this, that it's draggable on Y. And let's go ahead and play, and we should see the scroll bar update and be able to drag it. So as we scroll, the scroll bar moves, and it also resizes to show what percentage of content is being viewed, and we can also click and drag it to scroll. So now that we have things scrolling, and since we have our input manager, it's relatively easy to add some animations for things like hovering and pressing. So let's go ahead and do that. We'll add a new file here, which we'll call animations. Let's go ahead and open that up. So here we're just going to add a couple of animations that we can run using Nova's animation system whenever a grid item is hovered or pressed. So first we'll add a body color animation. We'll go ahead and import the Nova namespace, and we'll actually mark these as serializable so we can serialize them directly on the grid item prefab. And this will have a UI block as the target as well as a target color. And then we'll also track a start color. So on the first iteration of an animation, we're guaranteed that %done will be 0. So on that first frame, we'll set the start color to be whatever the UI block's color is currently, and then we'll lerp the color of the UI block based on the % value between start and the target. Perfect. So now we can also add a gradient animation, which will look very similar, but it will target a UI block 2D, and then we'll use the gradient color and also lerp that. Perfect. So now if we switch to the inventory item visuals, we can serialize those animations here. So let's go ahead and add a section called animations. We'll also add a duration, which we'll set to be about 150 milliseconds. And then we'll have this be a body color animation for hover animation, as well as unhover. And then we'll also have a press animation, but this will be a gradient animation. And release will also be a gradient animation. So now, while we're here, let's go ahead and actually add the functions that will run these. So first, we need to track 2 animation handles so that we can cancel the animations. And the reason I'm tracking 2 is so that I can run, since the press and hover will modify 2 different things, I want to be able to run these animations at the same time. So for hover, we will cancel whatever the current hover animation is. This cancel method is fine to call if this is an invalid handle. It'll just do nothing. And then we'll set the hover handle to be the hover animation run with the specified duration. Unhover will look very similar, except it's going to use the unhover animation. And then press and release will also look similar, except they will use the press handle and they will use their respective animations. Just release and the release animation. Now we can switch back over to Unity and open up our inventory item prefab, and we'll see our animations here. For hover, let's change the background color of the grid item to white. So we'll go ahead and set that here. And on unhover, we'll just set it back to the original color. And so the target for both of these animations is the root of the prefab. And for press, I want to add a gradient, but since we're already using it for this black gradient, let's just go ahead and add another UI block here, which we'll call the press gradient. And we'll go ahead and fill this, and I want it to render underneath the content, so I'll move it up in the hierarchy. And since the grid item will be white, assuming we're hovering over the item, let's make the gradient here this dark color, and then we'll set the body color to be the same thing, but alpha 0. And so that way the press animation will be something like this, but we'll set it to start with an alpha of 0. So let's go ahead and serialize that. So the target for both of these will be the press gradient, and when it's pressed, it'll be the dark color, and when it's released, it'll be the dark color with an alpha of 0. Perfect. So let's go ahead and change the body color here back to the original color. And the last thing we need to do is we need to add that interactable component that we added to the scroll bar to the inventory items as well. That way these inventory items will fire the gestures. So now that we have that, the last thing we need to do is we need to switch back to Visual Studio and subscribe to the gestures. So let's open up the inventory panel script, and here where we initialize the grid views, we'll register our gesture handlers. And you can actually subscribe to gestures directly on UI blocks. So let's say I had a UI block here. I can add a gesture handler to the block as well. But since we're using a grid view, we can actually subscribe to gestures by item visuals type. So here we can specify the inventory item visuals. And then in the handler, we're actually provided with the item visuals target. which is nice because we have implemented all of the functions that we want to call on the item visuals type. So we're going to register our gesture handlers on the grid view directly. So we'll have one for unhover, we'll have one for press, and we'll have one for release. And let's go ahead and add functions for all of those. And then all of these are just going to forward directly to the inventory item visuals methods that we implemented earlier. Unhover, press, and release. Now let's switch over to Unity and test it out. Perfect. So we have hover and press animations. Let's go ahead and add the functionality to be able to click on an item and pick it up and move it around. There are lots of ways to do this. The way we're going to set this up is we're just going to have a disabled inventory item in the hierarchy that we will enable and move around with the mouse once a user clicks on something. So let's go ahead and add a selected item pivot here. And I'm not making this a UI block because I don't need the layout system here. I just want to be able to move this transform directly to where the mouse is. And then I will just add the inventory item as a child of that. And I don't actually want the grid to render here, so I'll disable the body and I'll disable the shadow. That way we just have the item and the count. And I also want the item to be offset a little bit from where the mouse is. So since I will be positioning this pivot directly to where the mouse is, let's go ahead and set the alignment to top left here, so that way it's a little offset from the mouse. And now let's switch over to Visual Studio. In the inventory panel script, there's a few things we'll need to do. First, let's add a new section to our editor called selected item. Here we'll add some things that we'll need, including the selected item pivot, since we'll need to enable and disable and move that around. We also want to access the inventory item visuals for the selected item, and that way we can bind it to whatever the selected inventory item is. And in order to access this, we actually need a reference to the item view component that's on the selected item. So let's go ahead and serialize that. And in start, we can just get the selected item visuals from the item view. And now let's go ahead and add a gesture handler for click. This is where we'll actually do the logic to select the item. Since we're using two grid views, we want to know which grid view this inventory item visuals belongs to. So let's go ahead and add a helper that will do that for us. We'll call this get containing grid. This will take in the inventory item visuals, and it will also return the data source, since we'll likely need that. The way we can determine which grid view the item visuals belongs to is we can actually use the grid view's try get source index method. So this takes in an item view, which we can get from the item visuals, and it returns the index, but we don't need that. If this returns true, then we know that this belongs to the character grid, so we can set the data source to be the character items, and we'll return the character grid. Otherwise, we'll set the data source to be the Armory items, and we'll return the Armory grid. So now here in our click handler, we can get the grid view by passing in the target, and we'll also get the data source. And this will allow us to get the inventory item from the data source. And we're passing in the index that we actually get from the click handler, and the reason we get this index is because we subscribe to the click gesture on the grid view directly. So it handles actually figuring out what the index and the data source is and things like that, which is pretty nice. So now we want to do different things depending on what the current state is. So if there's a currently selected item, we want to do one thing, and if nothing is selected yet, we're going to do something else. So first we need to track the currently selected item. So if this is not null, then something already selected. Otherwise, nothing is selected yet. And if nothing is selected, if the clicked item is empty, we don't want to do anything. The user shouldn't be able to click on empty slots. Otherwise, first we want to remove from the grid, and then we want to select the item. In order to remove from the grid, we can just set the index in the data source to be the empty inventory item, and then we'll just tell the grid to rebind that index. And to select the item, let's go ahead and add a helper method for that, which will take in the inventory item. So we'll set the selected item to be the passed in item. We will make sure that the selected item pivot is enabled. We'll rebind the selected item visuals to the selected item. And then we want to start moving the selected item pivot around. So let's go ahead and add a coroutine for that. And this will just loop until we stop it. And in order to move the item, we need to know where the current mouse position is. So I'm going to abstract this behind the input manager. So let's add a try get current ray. And this may fail if the mouse is not present or something like that, or depending on what input modalities you decide to add. In the final sample code, you'll see that we have support for both XR controllers as well as mouse, so that's why I'm abstracting this behind the input manager. So if the mouse is present, we'll go ahead and screen point to ray the current mouse position and return true. Otherwise, we'll set the ray to default and just return false. So now, if we go back to our inventory panel, we need to add a reference to our input manager. And then here, we will try to get the current ray. And we also need to project this ray onto the inventory panel. So let's go ahead and add a try project ray helper. And this will return the world position. So first we'll create a new plane that is the inventory panel. So this will be, since we're looking at the back side, we'll use the negative of the forward direction. And then we'll use the inventory panel position. So if the plane can raycast, we'll pass in the ray, and this returns the distance. Then we can set the world position using that distance and return true. Otherwise, we'll set the world position to default and return false. So now here, if the input manager is able to provide us a ray and we successfully raycast that onto the inventory panel, then we can simply update the selected item pivot with that position. So now here in our select item method, we want to start this, but let's go ahead and start tracking it so that we can stop it later. And then here we'll start the coroutine. And then we need to make sure to call this select item function with the clicked item. Even though we're not done yet, let's switch over to Unity and test what we have out so far. That way we can make sure we haven't made any mistakes and see if we're on the right track. So we'll serialize the input manager, the selected item pivot, and the selected item view. We'll also make sure that the selected item pivot is disabled to start. And let's see if we can click on an item. Perfect. So we can, you'll notice that we're getting some flickering here, and that's because the selected item pivot, the selected item is coplanar with the inventory panel, but since we don't have a UI block on the selected item pivot, it's not a connected UI block hierarchy. And so it's not clear what order they should render in. So the way you can solve this is by adding a sort group to the selected item and bumping the sort order up by 1, and that way it won't flicker like that. Perfect. So let's make sure to apply that change here. And I actually am going to remove the interactable component as well because I don't want the selected item to be interactable since we're moving it with a coroutine. Now we can switch back over to Visual Studio and finish implementing our click gesture handler. So when an item is already selected, there are 3 scenarios we need to handle. One is when the clicked item is empty. Another is when the clicked item is the same type as selected. And another is when they are different types. So when the clicked item is empty, we just want to move the selected item into the clicked item slot. So we can do that by setting the item, the index in the data source to the selected item. we'll tell the grid to rebind that index. And then we'll also stop moving the selected item around. So let's go ahead and add a helper method for that. We'll just call this deselect item. This will stop the coroutine, set the coroutine to null. We'll make sure to disable the pivot, and we'll set the selected item to null as well. So let's go ahead and call that here. If the clicked item is the same as the selected item, then we want to move as many of the selected item count into the clicked item slot as possible. That may be all of it. In order to check, we'll take the minimum of the selected item count and then the number of available count in the clicked item slot. So this will be either the selected item count or whatever is available. So we'll add the count to the clicked item. We will tell the grid view to rebind that index. We'll subtract the count from the selected item. And if the selected item count is 0, then we will simply deselect the item. Basically disappears. All of it has been moved into the clicked item. Otherwise, we will simply rebind the visuals to the selected item so that it updates the count. And then the last scenario, when they are different type, we want to swap the clicked item and the selected item. So we'll do that by, again, setting the item in the data source to be the selected item. We'll tell the grid to rebind that index. We'll set the selected item to be the clicked item. And then we'll tell the selected item visuals to rebind to the new selected item. Let's switch over to Unity and test these changes out. First, let's make sure that clicking on an empty slot does nothing. If we pick up an item, we should be able to put it back down somewhere else, even between the two grids. Perfect. If we find two items of the same type, we should be able to combine the count. And if they add to over 50, it will only add as much to fill 50. And if we find two items of different types, we should be able to swap them around. Perfect. So the last piece of functionality that we'll add for this walkthrough is the ability to right-click on an item and drag to select a count so that you can split a single group of items into two. So let's go ahead and do that. We'll add a new game object under the inventory panel, which we'll call the count selector root. We'll add a UI block 2D under that, which we'll call the backing panel. We'll set the height to 50, and we'll just bump up the width to something like that. Perfect. Let's zero out the position here. We'll set the background color to be the same as the backing panel color, and let's go ahead and add a white inner shadow. Use that white color. I don't want it to be quite that bright, so I'll bump down the transparency, make it pretty subtle. We'll have the width and blur be 1. We'll get rid of the offset, and there we go. Now let's go ahead and add, well, before we forget, let's go ahead and add a sorting group to this and set the sorting order 1. Same thing that we did for the selected item, so that we make sure that it renders on top since the count selector does not have a UI block on it. Let's go ahead and add a UI block 2D for the image container. This will left align, we'll lock the aspect ratio and expand the height. We'll set the color to be white. And now let's go ahead and add the image itself. We will lock the aspect ratio here as well, expand the width. Let's go ahead and add a dummy texture in here. And let's set the color to white so it's full brightness. And let's also make sure to add a margin like we did for all the other images, just to give it some breathing room. And I actually want a gradient on this image container, so I'll use that lighter dark tone, but I'll actually make it a little, not so dark. Perfect. Now let's go ahead and add a count bar, which will resize, just eyeball, not being exact, something like this. We'll have it be the lighter dark tone. And now let's go ahead and add the fill, which we will left align, expand the height. We'll set the color to be the gold accent color. The size here doesn't super matter because we'll change it in code later. Something like that looks pretty good. And we'll also add a count badge here, similar to our inventory item. This one we will top right align, and let's go ahead and add the label first. We will shrink here as usual. We'll set it to be 20 for now. We'll use the bold font, and let's go ahead and use a font size of something like 320. We'll make this one be dark, like the inventory panel prefab. And let's go ahead and shrink the count badge itself. Add the padding to give some breathing room. We'll set min size as well. We'll make it a bit bigger this time since we're using a slightly larger font size for this. We'll round the corners as well here. And let's go ahead and add a gold border. Bump up the width a little bit. And let's just change things up here. We'll use an outer border this time. And we will set the background color to be the white. And let's go ahead and add that black inner shadow like we have on the inventory panel prefab as well. Perfect. Let's just reposition this so it's somewhere in the top right corner, something like this. And that looks good. So this is what we'll bring up whenever you right click and drag, and we'll adjust this count bar fill to show how many items you're selecting. Now let's go ahead and add a script so that we can add some functionality to this. We will call this count selector. And here in the count selector, first let's serialize some things that we'll need to access or modify. So that includes the count bar, as well as the count bar fill, the image, and the count label, which is a text block. We'll also add a function that we can call from the inventory panel to show the count selector at a specified world position with a specified inventory item. We need to track a max count. This is the maximum number of items that the user can select. We'll assign this from the item count since the user can't select more items than there are in the slot. We also need to figure out a delta because we'll be positioning the count selector transform, but we want the count selector to show up so that the center of the count bar is where the mouse is. So let's go ahead and figure out that delta. And this will just be the count selector's transform position minus the count bar's transform position. We can just add this to the passed in world position, and this is what we'll assign to the count selector transform position. Let's go ahead and make sure that the count selector is enabled. And also we can update the image based on the item's image. Let's also track a count, which we'll make public so that the inventory panel can access it, but we'll make it have a private setter. We'll start this off to be half of the max count. And now we can update the count label to be the new current count. And we'll also update the count bar fill size based on the new percent. And the percent will just be the current count over the max count. And now we can set the count bar fills size on X to be that new percent. And this is what we'll call from the inventory panel. But first we need to add right click support. So let's switch over to our input manager. There's several ways to do this. The way we're going to do this is by providing some user data. So let's create a type for that, which will have a primary pressed value and a secondary pressed value. And then we'll just add a property here for any pressed, which will just be primary or secondary. So let's go ahead and add a field for this in our input manager, which we'll just call data. And this is, instead of tracking separate bools here, we'll just assign this to the input data. This will be the right mouse button, and we can pass this into the interaction struct that we create. And then finally here, we'll just do any button pressed. So now we can switch over to our inventory panel, and since we want to handle left and right clicks differently, let's go ahead and add a helper to detect if it's a secondary button. This will take an interaction update. And to determine if it's a left click, we can just check the user data field and check the secondary pressed value. So in click, If it's a secondary button press, if it's a right click, we don't want to do anything, so we'll just return early. Now, every gesture struct has this interaction property that you can use to get the user data. And the other thing we want to change is our pressed handler. So let's go down here. We will still call target press so that we get the animation. And if there is currently a selected item, or it is not a right click, then we don't want to do anything, so we'll just return early. Otherwise, we'll get the containing grid view for the pressed item, as well as the data source. And now we can get the item that was actually pressed. And if the pressed item is empty, or the count is 1, we don't want to bring up the count selector. And we also need to get the world position, so let's use our try project ray function that we added earlier, and the interaction that is on the gesture has the ray, so we can just use that to try to get the world position. So if that fails, we'll also return early. Otherwise, we will show the count selector, but we need to add a reference to that. So let's go ahead and add a new section here for count selector. And now we can call the show method with that world position. And with the pressed item, even though we're not done yet, that's a pretty good checkpoint. So let's switch over to Unity and test out what we have so far. So we'll add the count selector script to the count selector root. We'll drag in the count bar as well as the count bar fill and the image and count label. We'll make sure that this is disabled to start, and we'll go ahead and serialize the count selector on the inventory panel. And now if we right click, it should come up. So it doesn't go away, obviously, because we haven't implemented that yet, but it looks like this is working so far. So let's switch back over to Visual Studio and finish implementing the count selector. Now we want the count to update whenever the user has right clicked and is dragging on an item. So let's go ahead and add a drag gesture handler. And if the count selector is not currently active, we don't want to do anything. So let's go ahead and add a isActive property, and this will just return if the game object is active. So if the count selector is not active, we'll return early. Otherwise, we want the count selector to update based on the new drag position. So let's go ahead and add a function to do that. We'll call this drag to position, and this will take in a world space position. First thing we need to do is convert that world space position into the count bar's local space. So we'll do that with the inverse transform point. We also need the width of the count bar, which we can get from the calculated size property. And let's convert that local space position into a distance from the left side. And this is just the local space position plus half of the width of the count bar. And now we can turn that distance from the left side into a percent by just taking the distance from the left and dividing it by the width. And now let's turn that into a new count by rounding that to an int. And this is just the percent times the max count. And so now if the new count is different from the current count, we want to update the count, which is basically exactly what we're doing up here. So let's go ahead and turn this into a function. And this will use the passed in count. And so we can call that at the beginning with the half of the max count. And we can also call that here with the new count. So now if we switch back to the inventory panel, we can call that drag to position method, and this drag gesture struct actually has a pointer positions property on it, which has the start, previous, and current position, so we'll just use the current. And the last thing we need to do is handle when the user releases the right mouse button. So let's go to our release gesture handler. If the count selector is not active, we will just return early. There's nothing for us to do. Otherwise, we'll get the grid and the item that was being dragged with the right mouse button. If the count selector's count is equal to the items count, then the user has selected the entire item. So all we need to do is set the item in the data source to be the empty inventory item and tell the grid to rebind that index. And now we can call select item with the pressed item. Otherwise, if the count selector's count is greater than 0, then we will create a new inventory item with the new count. So the count here will be the count selector's current count, and the item will be the same. And we need to subtract the number of items from the item in the grid. So let's go ahead and do that. And then we'll tell the grid to rebind at that index. And now we can select the new item that we just created. And the last thing we need to do is hide the count selector. So let's go ahead and add a method here to do that. And all this will do is just disable the game object. And now we can test this out. There's one last thing we need to do though. If we open up the inventory item prefab, we need to mark the interactable to be draggable on X. That way it will fire those drag gestures that we just subscribed to. But now we should be able to right click and drag to select a count. So we can do a partial selection. If we drag all the way to the end, we get the full item. If we drag down to 0, nothing should happen. And this brings us to the end of the video. We've used Nova's data binding, gesture, animation system to create this grid style inventory. You can scroll, click to move items around, right click and drag to select a count. Hopefully this gets you started with using Nova.